And we're back. All right, let's get going. Come on, there it is. Number uno. Evaluate the integral. Okay. So remember that this test is only a one-day test. It's not a two-day test. That's why there's only 10 or so questions. And it's basically, it's just over two sections, 5.5 and 6.1, right? And so that means it's only over U substitution and then areas bounded by curves. That's it. And it's a little bit more heavy on the U substitution piece. So, you had your partner quiz, which was only 7 questions, and some of you took the whole time. So this is alone. So now you're doing this alone. I think around 10 questions. I think that's pretty doable. Some of you guys are going to get it done pretty quick. Whatever, I think it's fair. Okay, the integral of 3 plus 4x raised to the 6th power. So what's my u?
3 plus 4x.
Pretty simple, 3 plus 4x. So u is 3 plus 4x. So du is 4 dx, right? The derivative of 3 plus 4x is just 4. So that means we divide that 4 over to the other side. 1/4 du is equal to dx. Okay, now let's plug it in. So that means that I have the integral of, now it's u to the 6th. And now in place of dx, we write 1/4 du, right, times 1/4 du. I like to bring the 1/4 out in front. Again, just preference here. 1/4 u to the 6th du. And now we take the antiderivative here. Excuse me. Bump it up 1 and divide. So that would be 1/4 u to the 7th over 7 plus c. Let's reduce that a little bit. 1/4 over 7 is 1/28. 1/28. So 1/28 u to the 7th plus c. And now don't forget that you cannot leave u in your answer. You need to put u back in. So 3 plus 4x needs to go back in place for u. Substitute it back in. I've got 1/28, 3 plus 4x raised to the 7th power plus c. And that's what I have as my final answer. Question on that one? Okay, let's take a look at the next one. Evaluate the integral of dx over 5 minus 2x. Now remember, whenever you have a fraction like this and you've got the dx in the numerator, you can pull it outside, right? You can really rewrite this to say this is the same thing as the integral of 1 over 5 minus 2x dx. So what's my u? 5 minus 2x. Okay, let's take the derivative. So du is negative 2 dx. Divide the negative 2 over. Negative 1/2 du is equal to dx. Okay, now I can plug that in as well. So we plug in our u as well as our du. So it's 1 over u, and then times negative 1/2 du. Let's rewrite it. Bring the negative 1/2 out in front. Negative 1/2, integral of negative 1/2 times 1 over u du. I'm leaving it like this because now when I take the antiderivative, what happens to 1 over u? Ln of x, or ln of u, excuse me, ln of u. So this is equivalent to saying Negative 1/2. Let me rewrite that. Negative 1/2 ln of u. I should say absolute value of u. I wouldn't take off if you didn't, but I should say absolute value. Plus c. So in the end, plug 5 minus 2x back in. Negative 1/2 ln absolute value 5 minus 2x plus c. Just double check that answer. Negative 1/2 ln 5 minus 2x plus c.
Mr. Lowry,
Yes.
I have a quick question.
I have a quick answer.
Why don't you take the antiderivative of negative 1/2?
Because it's multiplied by 1 over u, right? It's like it's a constant almost, and you take because it's a product in there.
Mm-hmm.
You don't have to take the antiderivative of that little piece.
Okay.
It's just whatever is multiplied by 1 over u.
Okay.
Now, if it had been like 1 over u plus negative 1/2, then I would be finding the antiderivative of that piece.
Okay.
But because it's a product, you don't have to. It's like a constant multiplied to it.
All right. Well, then could you do that with, say, for instance, u is being divided, and you just pulled it out, like u over 4, and you pull out 1/4.
1/4.
U, and then you don't have to take
Yep.
it. Okay.
Yep. Then you don't have to worry about it. All right, let's take a look at number 3. Yeah, come on, where you at? Where you at? I used a weird last year when I was making all of my stuff for this calc class. I used a weird font, and I really regret using that font because now if I pull it up on any other computer, it's like it's weird. Like I used this Tecton Pro font. I do not know why I used that font. I should have just done Times New Roman.
I like it though.
I like it too, and that's why I was like, oh, start doing. But then once I did like one quiz,
Yeah.
I had to keep using it. But whatever. Evaluate the integral ln of x to the 4th over x dx. All right. So we've got u is what? ln of x. Okay, so du is 1 over x dx, because the derivative of ln of x is 1 over x. All right, now I'm going to rewrite this piece in here, because that is really equivalent to saying the integral of ln of x to the 4th power times 1 over x dx, right? If I have anything in my numerator, I can remove it out front. And that's going to help us here because now I see the 1 over x dx right here. So du is really this whole chunk. So this is equivalent to saying, no, blue please. This is equivalent to saying the integral of u to the 4th du, which simplifies it a lot, right? And now we find the antiderivative of u to the 4th. So u to the 5th over 5 plus c, which is quite simply just, okay, u is ln of x. So ln of x to the 5th over 5 plus c. Now I'm thinking something. No, I don't think that. No, I don't think so. You want to know what was going on in my brain?
Yes.
Weird stuff. That's what's going on. What if there's something on a power, like if there's a power on a log, what could you do with that power? Put it in front, right? So I was thinking you could maybe do this. However, this is ln of x raised to the 5th power. It's not ln of x to the 5th. You understand? So I was thinking that you could maybe do that, but you can't. You can't do that because that fifth power is on the whole ln of x, not just the x. If it was just on the x, then you could bring it out front, and you would be able to simplify it like that. Sorry, weird tangent. All right, let's take a look at number 4. Now, this one does have a little bit of an error in the key, but it did not affect the final answer. That's what we decided yesterday, correct? Okay. Now, let me try to correct that here then. All right. So I've got the integral of sine x times sine cosine x dx. All right, so u in this case is cosine x. And this is where I think the error came, because I said du is just sine x dx, and that's not true, is it? What is cosine? What is the derivative of cosine? Negative sine. Negative, yeah, that's right. Negative sine x dx. Which then I can flip the negative over to the other side, so negative du is equal to sine x dx. And the reason why that is valuable here is because this can be transferred into the integral of sine cosine x times sine x dx, right? This piece here is what I'm putting over here. And that is nice because that's just negative du, right? So I can say that this is equivalent to being the integral of sine of u times negative du. So in other words, negative sine u du. I don't really need those parentheses, but whatever. And I think in the key it has a positive sine u du. All right, now, yeah, it does. I'm looking at it right there. Now I take the antiderivative of sine. What is the antiderivative of sine? Negative cosine. So this is negative cosine u plus c, which is positive cosine u plus c. And then we plug u back in, which is cosine x. So that means we've got cosine of x plus c. It's like one of those ones where, like, if I showed you this at the beginning of the year and said you'd be able to do this, you'd say, no way. It's really, I mean, that's kind of a simple one anyway, you know?
Mm-hmm.
As long as you know your trig derivatives in integrals.
That's like the hardest part is like knowing the
rules.
derivative from the antiderivative. Like remembering that.
Especially, with these integrals and knowing the u substitution, keeping it separate where the derivatives and the antiderivatives are. That's the really difficult part about this piece. All right, any other questions on that one? You guys good back there? Yeah. Okay. All right, let's take a look at 5. Okay, so we've got, what do you think our u is going to be? 3 plus e to the x. Okay, so that means du, well, the derivative of 3 just goes away. Remember, e to the x is e to the x dx, which is good because now, take a look here. If I reorder this, this is going to be the square root of 3 plus e to the x times e to the x dx. And that's exactly what we see here. So I can replace e to the x dx with u and say, well, that's equivalent to saying the integral of the square root of u du, which is a really simple statement, right? And that's really the square root of, not the square root, the integral of u to the 1/2 power du. And now we can do the antiderivative. Again, if you want to use decimals in your powers, that's completely fine with me. You want to use fractions, be fancy, go for it. So this is u to the 1.5 or 3 halves over 1.5 plus c. And then we can just plug that in. 3 plus e to the x, which is equivalent to saying 3 plus e to the x to the 1.5 over 1.5 plus c. If you look at the key, I did it in fraction form, which would be u to the 3 halves over 3 halves, but keep, change, flip, divided here, right? Divide by the reciprocal or multiply by the reciprocal. That would turn into 2/3 u to the 3 halves plus c, which that's what you see in the key. 2/3 of 3 plus e to the x plus 3 halves plus c. And that's the answer you see in the key. These two statements are equivalent.
Are you okay if we just leave the?
Yeah, decimals are fine.
Okay.
Yeah. But if you want style points, which don't count for summative points, then do fractions. All right. Looks like we're on 6. All right. Sine of 6 minus 2x. Oh, now this is the one that is incorrect in the key, correct? Yes? This one should not have a negative out front, and there is a negative I see in the key. All right, let's take a look here. Well, u is 6 minus 2x, obviously. So that means du is negative 2 dx. Okay, so that means I've got a negative 1/2 du is dx, which that was all well and good in the key. But what happened here is I screwed up my trig rule. So the integral of sine u times negative 1/2 du. Bring the negative 1/2 out front. The integral of negative 1/2 sine u du. And now we can say, well, the antiderivative of sine is negative cosine, right? The antiderivative of sine is negative cosine. So that means that's going to be negative 1/2 times negative cosine of u plus c. And now we can see that the negatives will indeed cancel out. So that's a positive 1/2 cosine u, which when we plug 6 minus 2x back into u, that's going to be a positive 1/2 cosine 6 minus 2x plus c. Don't lose sight of the end goal. Like, what are we doing here when we're taking these integrals? What are we doing here? We're finding an equation that you could find the area under the curve for any 2 points where if you bounded it, right? So for this equation, sine of 6 minus 2x, if at any point you wanted 2 points in between, and you wanted the area under that curve, that's the equation that's going to give you the area under that curve. Plug in top minus bottom, done. Which kind of leads us to the other questions that we have on the review. So that was 6. This is 7. Now I said 7 was the kind of the only funky one of the bunch. So we've got the integral of x times square root of x plus 3 dx. And now why is this weird? Well, obviously we can see that the u should be x plus 3. So du should be just dx, right? So you might be thinking, well, why is this so difficult then? Because now I can say this. Well, the integral of the square root of u du, but wait a sec. Where'd that go? Right? I still have an x that needs to sit here. We have not substituted anything there for that x, right? It's not like du is x dx. No. du is just dx. So here's what I have to do. And we did this a couple of times in the notes, but this was not on your partner quiz. I have to take this piece in here and say, well, if u is x plus 3, let's find an equivalent statement for u. So u minus 3, just subtract over the 3, is x. U minus 3 is x. So therefore, we can substitute that into our integral here and say that that means that the integral is going to be equal to u minus 3 times radical u du. Have I replaced all my x's with u's now? Yeah. So now, once I reduce this down, and I have to reduce it down before I do anything else, once I reduce this down, then I will be able to find the antiderivative. I couldn't do it yet because I had an x still in there. So let's reduce that down. Now, to reduce that down, I'm going to say this. The integral of u minus 3. I'm going to make that a u to the 1/2 power du. And then I'm going to distribute that in. Okay, so that's the integral of. Now, don't forget, when you're multiplying with exponents, you're adding. When you're multiplying with bases, you're adding the exponents. So that's like saying 1/2. If you want to do fractions or decimals, it doesn't really matter. It looks like I did fractions. I'll do decimals here then. If you want to see the fraction version, it is in the key. So that is a u to the 1.5 minus 3 u to the 0.5 du. You're good.
All of a sudden.
All of a sudden.
So
I was doing my front walkover, and then all of a sudden, had to do some u substitution. Okay, so we got u to the 1.5 minus 3 times u to the 0.5 du. All right, now I find my antiderivative. So kick it up a notch, u to the 2.5 over 2.5 minus 3 u to the 1.5 over 1.5 plus c. And now all we need to do is just plug in the x plus 3. So we've got x plus 3 to the 2.5 over 2.5 minus 3u to the, 3 times x plus 3 to the 0.5 over 1.5 divided by 1.5 plus c. Now that, I'm okay with that. There are some little housekeeping issues that we could take care of. This 3 divided by 1.5, remember, 3 divided by 1.5 is 2. So we could do this as a x plus 3 to the 2.5 over 2.5 minus 2 x plus 3 to the 1.5. But I wonder what 1 over 2.5 is. 0.4. So that's another thing that we could say. We could say 0.4 to the 2.5. Which makes sense because my key says 2/5. Oh, I'm looking at my key right now. I forgot this exponent. I forgot that exponent on my key. Yeah. That should say a 2.5. It's above. It's like the step above it. I just forgot to carry through. 0.4 x plus 3 to the 2.5, or as a fraction, 5/2, minus 2 quantity x plus 3 to the 3/2, or 1.5, plus c. C? Bueno? What if you were in a math class and the teacher was Spanish? And like, for real?
Yeah.
I think about that a lot. Twice already? Oh gosh.
Yeah, you do think about it a lot.
But now when you say like
French.
dx,
I have a lot of new thoughts that are not new. Right?
Yeah.
Hey, did you hear about the cannibal who showed up late to the potluck? You guys know what a cannibal is?
Yeah.
Yeah.
You guys hear about the cannibal who showed up late to the potluck? He got the cold shoulder.
Yummy.
Yummy. Yummy.
whenever you say like
Sorry, I'm more
dx,
disappointed that you thought we didn't know what a cannibal was.
I don't know.
You don't know what a cannibal is?
I know what a cannibal is, but like I don't know
Do
you.
you really?
I know you guys know math, but I don't know you know other things.
Do I really know that?
Does anybody?
Do we know that?
You know, if you think about it, how
Illusion.
right? It's all man-made. Didn't we have this discussion before too? All right. Evaluate the integral from 2 to 6 of dx over 3x minus 2. So this is very similar to one of the other problems we've already done, but now instead of indefinite integral, we are doing definite integral. Okie dokie. Okay, so my u is obviously 3x minus 2. So du is 3dx. So 1/3 du is equal to dx. Now, the reason why we're doing 1/3 du, because we just need a dx, because now if we do 2 to 6, we can write this as 1 over 3x minus 2 dx, right? So let's take u and plug it in. Now, when I do that, watch what's going to happen here. I'm going to leave off the definite part of the integral. So 1 over u, and then times 1/3 du. Alrighty, now I have to tack back on my definite parts of my integral, right? I have to put those back in. What's this 2 going to turn into? 4. 3 times 2 is 6, minus 2 is quattro. 6. How do you say times?
Times.
6 y 3 es 18. Menos 2 es 16.
I'm confused now.
3 times 6 is 18, minus 2 is 16. And now we can evaluate that, right? Now we don't even have to plug x back in. Because we've changed the definite part of the integral. You good? Okay.
I just took a minute to process. I thought it was 2 to 4, not 2 to 6. I was like, what?
Yeah. Okay. So now let's rewrite it a little bit. This is 1/3 integral from 4 to 6. Ooh, that is a fancy integral symbol there. 4 to 16 of 1/3 times 1 over u du. And now when I do the antiderivative, this is going to be 1/3 ln of u plus c. Do I need the plus c?
No.
Nope, but I do need a vertical line with 4 and 16. Do I even need the absolute value parts of the symbol? No, because this is 4 and 16. I'm not going to have any negatives, so it does not matter. What if it did? Then do the absolute value. There you go. 1/3 ln of 16 minus 1/3 of ln of 4. Let's just plug that all in our calculator. 1/3 of ln of 16 minus menos uno. I don't know. I can't do that. I don't know how to say that in Spanish. Uno over tres. ln, L-A-N-A. De. That kind of sounds like Greek. Quattro. Yeah. 0.462. That's what I have in my key as well. 0.462. You want me to teach it all in German now?
Yeah.
I just do it sounding really mad.
I can barely understand it.
You can use it on count.
Yeah.
Yeah.
Let's do the math. That's really bad. This is being recorded. It's like,
Oh, people, I hope people
is that
watch
like
this.
insensitive?
Yeah.
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 You know, I said I enjoy your struggle.
Appreciate it.
Yeah.
All right, number 9. So now starts the section 6.1. And just a couple questions out of 6.1. It's not too bad, even these ones. Sketch the graphs and then find the area enclosed by the curves. Sketch the graphs and find the area enclosed by the curves. You will have your graphing calculator for this, so you can find whatever you need to with your graphing calculator. I'm going to do it without a graphing calculator.
Oh. You can use it on
Flex on
Okay.
them. Whoa. Oh my god.
I know, my back cracks really
It's
a lot. Okay.
It's more.
I should have gotten closer to the
Yeah.
mic. Anyway, what is this? Does anybody know? That's a quadratic, but what's the transformation? Does anybody know? What's that minus 3 going to do? To the left, to the left, to the left, to the left. I was going, okay. Oh, no. Wait a second, it's going to the right.
Yeah.
Wait.
Sorry.
It's the opposite.
I trusted you. I
That was
trusted
your
you.
I still don't know the chain rule.
All right, so we go 1, 2, 3. So here's my parabola. I mean, it's just a sketch, remember? And then 4x. Kind of a steeper line, but sure, here. Something like that, right?
So it doesn't have to be exact.
No.
Like grading on like.
Why are we even
This
sketching?
has to look like no, so we know what to shade in.
Yeah, and we know what's on top and what's on bottom, right? That's really what the goal is of the sketch. Because you visually need to see what's on top, what's on bottom. This is going to be the shaded region that I want to find. And now I know I can set up my integral in this way. The integral of the top minus the bottom. Now, I have to have my parameters here. I have to have my intervals, right? So how are we going to do that? Well, again, you could go into your calculator, graph it, second calculate, intersect, but we got this. What we want to do is really set these two things equal to one another. We want to find when x minus 3 squared is going to be equivalent to 4x. We can solve that. Just FOIL this guy. Okay, x squared, we've got a minus 3x and a minus 3x, so minus 6x. Negative 3 times negative 3 is a positive 9. Subtract over the 4x. What are factors of 9 that add to get to negative 10? 9
and 1.
Right, negative 9, negative 1, right? X minus 1, x minus 9. So that means I've got x equals 1 and x equals 9. And those, I'm kind of off on my diagram, but you get it, 1 and 9. 1 to 9. Because that's the region that's bounded there. Again, you could have done that in your calculator. You could throw those both in your calculator, find second calculate intersection point of the first one and then do the second one and get those x values with technology as well. Okay, so now I need to evaluate this, right? I need to reduce this down before I try to find the antiderivative. I need to reduce it down before I try to find the antiderivative. So we go 1 to 9 of 4x minus, well, didn't we just multiply this? Isn't that just x squared minus 6x plus 9? X squared minus 6x plus 9. Don't forget that you have to subtract it and keep it in parentheses, because if you don't do that, you're not going to remember to distribute the negative. So that gets us the integral from 1 to 9 of negative x squared. So that's a positive 6x and a positive 4x plus 10x minus 9. Oh, I'm forgetting my dx. Okay, and now we can evaluate. So this is going to be a negative x over 3 to the third. So negative x to the third over 3 plus a 10x squared over 2 minus 9x from 1 to 9. Everybody follow me there? And you know what? For good measure here, I'm just going to make that 10 over 2 a 5. Negative x to the third over 3 plus a 5x squared minus 9x from 1 to 9. All right, let's plug in 9. We got 9 to the third divided by 3. So that's a negative 243 plus a 5 times 9 squared minus 9 times 9. So all said and done, 81. 81 minus, and now we just plug in 1. Okay, so that'd be a negative 1/3 plus 5 times 1 squared, so just 5, minus 9 times 1, so minus just 9. So negative 4.3 repeating, which gets me an 85.3, because that's a big plus, right? Minus negative is a plus. So 85.3 repeating. So I got on my key as well. You ready? Last problem? Not really, because we got exam review.
Yeah, don't go there, Ray.
You stole my thunder.
Sorry. I was thinking it. I was thinking, this is the last one. No, not really. Last test review problem. Okay. All right, let's sketch the graph. I don't want to do that yet. Okay. What is this? That's a down 5, right? Positive. You talking to me? Are you sure? Oh, no, she's not talking to me. I'm positive, okay? Relax. Okay? So this is the blue one here. Let's do this one in red. Okay, so can't that be rewritten as negative x squared plus 3? So it's reflected downward and up 3, right? Reflected downward and up 3. So if I go boom, boom, boom. No, it's not going to be that.
I want it to go like out like that, so you just have like a little like crescent moon shape.
All right, so I see the region bounded, right? I know what I want. I want this area, just how to get that. Kind of looks like a football. That is going to be the integral of, now remember, what's on top? The red. Negative x squared plus 3 minus the bottom, the blue, x squared minus 5. Now what we have to decide is, where do we go from and to? What is our interval? Well, again, you could go in your calculator and plug this in your calculator and find it, but honestly, this one's a heck of a lot easier just finding it algebraically. This is 3 minus x squared is equal to x squared minus 5. Okay, add the x squared over to this side, that's 2x squared. Add the 5 over to this side, that's 8. Divided by 2 is 4. Plus or minus 2. Because there's no b terms. I can just solve directly and use square roots. So negative 2 to 2. Which makes sense because there was no shift left or right. So these are both symmetrical on the y-axis. So it makes sense that it's going to be even across the x-axis, or y-axis, excuse me. All right, so that means we got negative 2 to 2. All right, we got negative x squared plus 3 minus x squared plus 5, right? Don't forget to distribute the... Oh, I forget my t-axis.
For that one, did you just distribute the negative?
Yeah. All right, so that's going to be negative 2 to 2 of negative 2x squared plus 8 dx. And now we find the antiderivative. Okay, so that is a negative 2x to the third over 3 plus 8x from negative 2 to 2. Okay, top minus bottom. Negative 2 times 2 to the third, or just 8, divided by 3, plus 8 times 2, or just 16. So that gets us a 10.6, repeating, minus, and now we plug in negative 2. We have negative 2 times negative 2 to the third, oops, not squared, 2 to the third, and then we have, that's divided by 3, plus 8 times negative 2, plus 8 times negative 2. Gets me a negative 10.6, which really makes sense. Because if this is truly symmetrical about the y-axis, isn't the left side shaded region going to be the same as the right side shaded region? So all said and done, if I've got that times 2, that's going to be a positive 21.3 repeating. 21.3. Does anybody know another integral I could have used to solve for this? Remember, didn't we say that if it's symmetrical about the axis, couldn't I have done this? Couldn't I have said 2 times from 0 to 2, right? If we know that it's even, if we know that it's symmetrical, we could have done 2 times 0 to 2, which would have gotten us 2 times 10.6. Okay. It's really not much different, but is what it is. All right, I'm going to stop the video real quick.